Good morning. So I'm on a little bit late today. I I had some stuff to do in the morning, so I wasn't on as early as I was in previous days. And that's okay. Like I'm talking about studying and how to sort of approach your studying schedule. And one of the things that I did last week is I did quite long hours, and part of that was because I knew that there was going to be some inflexibility, I guess you could say, right now. So it's nearing the end of the project, and so how am I feeling about it? Well, it was definitely, or it is definitely, I shouldn't say the past tense yet, we're not done yet, but it's definitely a harder class than I had anticipated going into this. And this is something that is very common. It's not to say that I was super arrogant and thinking, oh yeah, it'll be easy, and then now I'm blindsided. It's just that whenever you go into any kind of learning project, you actually don't know what the difficulty is going to be. And this is partially just because if you could imagine doing a goal that doesn't involve much learning, meaning something you've done before, you have experience with, and you just have to do it. Well, in that case, it's often easy to plan for it because you kind of know what will be involved to get you to the destination. Learning projects, in contrast, are the very opposite of that you have to actually discover what you need to do while you're doing it. And so this can mean that for some classes, they're actually a lot easier than you think they're going to be because you either have some of the background concepts or facts or ideas, or the new ones you're learning are just not as much work for you to memorize and understand and practice. Now, for me, for this class, there were a couple reasons why it was hard. I knew it was going to be hard going in, but why it was harder than I was anticipating. So one is just the background. This class has 6 prerequisites: 1801, 1802, 1803, 801, 802, 803. So that is single variable calculus, multivariable calculus, differential equations. And then on the physics end, classical mechanics, electromagnetism, and waves. So there's 6 different classes I was supposed to take. I have done 5 in the past, but the 5 that I have done, I did about 8 years ago. So I knew there was going to be relearning. I knew there was going to be stuff that it was like, oh, right, how do I do that? And having to remind myself. And there was. I don't really regret doing it this way. I mean, one could say, well, why didn't you maybe study up on those subjects first or prepare before you go into this? But as I said, I think this was going to be a difficult class, and I think that I approached it in the most efficient way possible, or close to the most efficient way possible, given my constraints, given the background that I had, given my time constraints, all of those kinds of things. So I don't really have any regrets about that, but it did turn out to be quite challenging. The calculations are quite challenging. The problem sets are quite hard. So it's taken me more than, let's say, it did when I was doing the MIT challenge. So what I've been doing is basically just sort of chunking it down and breaking it into small pieces and working up piece by piece. And so I like to think of these big projects as breaking down into smaller and smaller chunks until you kind of know what you're after. So the first goal was to try to get through all the lectures. I split that into 2 chunks. So I did first 10 lectures, first 5 problem sets, and then the rest of the lectures. So I did do some problem sets in between. Given the difficulty of the class, I think I wish I had fine-grained it a little bit more. I think that the more you fine-grain, the more you're going to waste less time having to recover other lectures because you're going to understand it better. I don't think it was necessarily bad the way I did it here, but I might have split it up into 3 or 4 chunks just because I think that would have been a little bit easier. I wouldn't have had as much, oh wait, but I didn't fully get that first idea when I was covering in the lecture. I don't think it made a huge difference, but a slight thing. And so I did all the lectures. Then it was first pass of the problem sets, which took a while. The problem sets were hard and they're long, and I don't have any, I can get feedback from them by looking at the solutions, but if I don't want to do that, that means a lot of like, what do I do here? And like you're sitting for like 10-15 minutes. So I did the first pass of the problem sets, and then after I did that, I made this little sheet. I'll show it right here. And did this in 2 parts. First, I went through all the problem sets and wrote down all the concepts I didn't get right off the bat. And I also put questions that I hadn't done and questions that I redo. So I just basically reviewed the whole problem sets. And then I sort of rewrote this here where I put concepts, facts, and skills. Now these lines are blurry. some of these things that you could say are a fact are really more of a concept. Some of the concepts are really more of a skill. So these are not crisp, clear categories. But the reason that I separate them this way is because not on like what, you know, what are they really, but rather what is the right way to think about them. And so for me, concepts are things that you should do something like the Feynman technique. Your goal is to develop an understanding of them. Facts are things that you need to memorize. So that means you need to sort of repeatedly drill them. And skills are things that you need to practice. So the way to get better at it is through practice. Hello, cat. I have a cat visiting me right now. And yes, please put your tail right there. Get over here. Hey. So when I was working on this, I've went through, did some Feynman techniques. I did some Feynman techniques even for the skills end. I've made some flashcards. I should probably cross some of these guys off because now I have, you know, I will cross this. So I'm going to just cross these guys off because I've actually done these now. I think we want some trig identities. Integrals of Gaussians. Okay, so I've crossed some of these off. I didn't cross them off. And so I've done some of these now. And in addition, I've been working through the problem set for a second pass. So this means I'm doing the same questions over a second time. Now this has an obvious flaw, which is that you can learn to memorize the form of a very specific question rather than learn the principles that it contains. So generally, when I have the opportunity to take questions that have different feedback, I like to do different questions. So for instance, if I had multiple problem sets from different sessions of this class, from different sessions of this class, then I would probably do that. So I would probably do ones that I know that I have new questions for. I can do new problem sets. On the other hand, if I'm doing ones that I have already done before, there is that risk of memorization. But at the same sense, I think there is still a benefit for doing them. So you have to be cautious about it. But given that I don't have any other problem sets, I still think that doing a second pass of these, for instance, is better than, let's say, trying to find a random set of problems, or let's say going through my textbook, which maybe doesn't have the same kinds of questions I'm going to face on the exam. So so I have been doing a second pass, and you can see here I've crossed a bunch of these off, which means that I have made progress through this second pass. I've added some here. I might do this one in pen, just so I can distinguish third pass from. So basically, the ones that were circled were ones that for whatever reason, I didn't do the first pass. And the ones that aren't are questions that I have done, but I got wrong, and they were difficult for me. And I think that they would be worth redoing. And so I've gone through these, and I've crossed a bunch of them off. Now, I haven't done all of them right in the second pass either. So there's still a lot of difficulty. So if I were to overall give my sense of how I'm doing in this class, I would say that there's a reasonable chance that I could pass the final exam by a kind of, you know, could I get 50% on the final exam benchmark, which is, I think, still a reasonable benchmark to consider for learning it. But there's still a lot of stuff that is not perfect. So I was hoping to get closer to the perfect stage than just the passing stage at the end of this month-long period of time. But I don't really have any regrets about how I proceeded and how I've done things. So my goal right now is I've got today, what's left of the morning, this afternoon, and tomorrow to try to work through the rest of these guys here. There's a few more Feynman techniques I wanted to do. Now, I had considered the possibility of working a little bit over the weekend. I'm not going to make that decision until Friday. It's normally I don't like working over the weekend. I like to leave the weekends free. But this is the last weekend of the project, as well as I just happen to have a kind of free schedule this weekend. Hello, cat. Okay, you getting down? All right. I happen to have a little bit of a lighter schedule. So, I mean, it's also easier for me to work a bit over the weekend. So I'm not going to do full days if I do it over the weekend, but I might work a little bit further, especially if I don't get finished this, because I definitely wanted to get through at least second pass of these guys. And if I can get through this and all of this, I think I would be satisfied with going forward to doing the exam. Now, as I said, I don't think I've reached a perfection with this, but I'm going to at some point reach the limits of what I can do with the materials I have. And so that means that for me, honestly, like one of the things doing the MIT challenge is that I would do the class the best I could. I would aim for a pass, which in my case was trying to get a 50% or higher on the final exam using some kind of reasonable grading scheme. Because that's certainly not perfection of knowledge, but then as you go forward, you're kind of practicing the underlying core ideas in the next class. So for me, I think if I were to move on to 805, 806, the quantum physics 2 or 3, that's going to still work on this material because they're cumulative classes. So there might be some specifics of these classes, but compared to my overall goal of understanding quantum mechanics, at some point it's going to make more sense to just go forward into 805 and 806 than to continue circling this material. So I'm pretty happy about how things have gone. I feel like I've made a lot of progress. This was a difficult class, but things have been going forward. And yeah, it's something that's been interesting me for a long time. And so, you know, I don't think most people, when they think about quantum mechanics, think that it's an easy subject. So for me, just being able to learn it on my own this way, I think is accomplishment I'm happy about, you know, even if it's not like breaking any speed records or I'm going to be, you know, breaking records for, you know, getting some excellent score in some period of time. So with that said, I'm going to continue working on this. So I was working on 7.5, which was, let me just pop this open here. 7.5 was, scattering off of the delta function well. So let me just lower my blinds a little bit. It's a bit bright for the camera. All right. So I remember where I was is that I had set these guys up and it was, all right, time to calculate them. I don't know whether I should leave it in A, B, and C. I'm just thinking right now. I guess because I can divide all this out by A, so I have B by C, and then just let that equal to R, and then differentiate it. So yeah, this should be fine. Okay. All right, so we want to figure out how many are reflected when we fire it at this thing. And so we need to solve for this relation of IK in terms of R and T. So let's start with this one here. This one I've been getting a lot of questions wrong, and I think it's just because it's a kind of tedious calculation. So these are not my favorite problems to do. I tend to make little mistakes or not see simplifying identities, and they just take a while. So let's go. So I'll say R is equal to what? Well, we're going to have T e to the I k x minus e to the I k x divided by e to the minus I k x. So we can just set this equal to T minus 1 e to the 2ikx is R. All right. And then let's solve for our t here. So we're going to have ik e to the ikx minus ik, and then t minus 1 to ikx e to the minus ikx is equal to ik t e to the ikx plus 2m naught over h bar squared. All right, so we're no, this is going to cancel with this 2, and let's go. So minus ik. Bring this guy over. Yeah, let's bring this guy over and then just substitute everything out. So we've got let's go e to the ikx, and then this is ik minus 2 ikt. It's 1. So what can I do here? I kind of want to solve for t, I think. Yeah. So this wasn't really that helpful. So we divide out everything by e to the ikx, which is e to the minus ikx here. T is equal to 1 minus ik. Oops, very low on erase here. 1 minus ik So we're going to have plus, and this is I and k are going to cancel, so we're going to have plus 1/2. 2 is going to cancel. You get a minus sign. Get the eyes up above. So I've solved for 2 of these guys, but I don't need 3 equations. Just got 1 boundary condition. And that's condition on its derivative. So that's going to be t minus 1 e to the 2ikx complex conjugate. T minus 1, I can do it here. All right. Yuck. Can we get this simplified? Complex conjugates, just all going to go to minus i's, minus I, plus I, minus I. And so we're going to have to the S times y over 2k 2ikx plus 1/2 e to the 2ikx A whole lot of terms there. Do I want to try to do all 16 of these terms, or is there something I'm missing that can simplify this? Screw it, let's just do it anyways. All right. So these two are going to give us minus I times I. It's going to give us 1. And this is also going to give us 1. So we're going to have 1 over 2k. Let's do... Yeah, let's just do it in order. So this is going to give us... All right. This guy's going to give us m v naught to k squared h squared to the minus ikx. And this final guy is just going to give us plus I to k. All right, now this one here, we're going to have, this is now plus I over 4k, so those guys are going to cancel. Here we're going to have plus 1/4. Here we're going to have v naught 2k h bar squared e to the minus ikx times this is going to just give minus 1/2. All right, this guy. All right, negative I and I are going to cancel for 1. So we're going to have m v naught over 2k squared h bar squared e to the now it's ikx. This one here is going to be plus Nope, minus I m v naught over 2k h bar squared e to the again plus ikx. These ones we're going to get canceled, so it's going to be plus m squared b naught squared over k squared h to the fourth. And then finally this one here, we're going to have plus I m v naught k h bar squared e to the ikx. And lastly, this guy, we're going to have minus I over 2k k squared, or oops, k, oops, I'm running out of space here, k h bar squared, and we're going to have e to the, is a minus, forgetting a minus, right? It's not plus half, it's minus half. Kx, and then we're going to have here plus 1. So a ton of this is going to cancel. Of I 2k, I 2k. We're going to have that all we have for cancels? This is a half, and what was this one here? One, two, three, 4, 1, 2, 3. So it's minus a half. And this one was minus 1/2. Okay. Let's try rewriting it. You know what? My pencils are getting really dull. I'm going to just take this opportunity to give them a quick sharpen. All right. So I'm going to try to copy all of this over to the other side. All right. Okay, I have to be very careful copying this. This is one of the things that I don't like about doing these problems on these two sheets is when I have to flip from this page to this page. There's always a risk of making some kind of transcription error. So be careful here. We have 1 over 2k. plus m v naught over 2k squared h bar squared e to the minus ikx. And then we had a canceled, then we have two more canceled terms plus 1/4. And we have plus im v naught, im v naught over 2k h bar squared e to the minus ikx. Minus 1/2 plus m v naught over 2k squared h e to the ikx minus im v naught over 2k h bar squared e to the ikx plus m squared v naught squared k squared h bar to the 4th and plus im v naught over kh bar squared e to the ikx. And then I have minus 1/2. And then I have minus im v naught over k h bar squared e to the minus ikx plus 1. Let's just make sure I got these signs right. I think that's right. Okay, all right, so some things are going to group right away. Well, we have a bunch of constants here. So minus 1/2, and 1. These guys all cancel. And then we just got that plus 1/4. We're going to have... Are these plus or is that one minus? No, there's a minus sign up there. This guy and this guy are only off by 1/2. So I can just cancel this and write minus here. And this one here, I can cancel and just get rid of this. What else? These guys just have the opposite. This e to the ikx plus e to the ikx is going to be cosine, and we're going to get rid of the 2. So let me just write this down here. I've got 1 over 2k. This is going to be plus m v naught over k squared h bar squared of cosine kx. And then, so I'm just going to put these up here once I've moved them so I can keep track. And then I have, this guy doesn't have anything here, so I'll put plus 1/4. And then these guys are if we have, let's say, IA e to the I alpha minus IA plus I alpha. Which one is this? This is hyperbolic sine or okay, well, if we factor off the I, we have AE, the minus I, minus A plus I. So this should be minus sine alpha, right? But minus I sine alpha is, this is sine H alpha. I actually have this on one of my flashcards. So this is why you don't always need to have sine H in terms of sine is, yeah, minus I sine. So this is why you don't always need to do space repetition for everything, because like, this is an example of me recalling a fact in context. So space repetition, sort of the assumption of space repetition is also that there's no other exposure to the ideas. All right. So if this is sine H, and that means we have plus mv naught kh bar kh squared. And then this is sine, hyperbolic sine kx. Should we multiply everything by k? We've got distinctly less terms than we had before. E, M, and V naught. So E is equal to, what is it, 2m over h bar squared k, no, other way around. H bar squared k squared over 2m, that's E. It's another good one to have memorized. I think that's what this is. Let's just think units here. You have kilograms squared meters to the fourth, second minus 2. K is 1 over meters. So we're going to lose 2 of these guys. And that is an energy. Okay, so it is right. So E is equal to this. Then this is going to be, let's rewrite it in terms of 1 over 2K plus 1/2 so I think we want, yeah, this is cosine. And this is only K squared. I don't think I dropped a square anywhere here. So if we just take energy, we have to add a square to the top, right? So this is going to be K squared V naught squared over E squared. No, I think I did that wrong. Oh, this is not working out as I would like it to. H bar 4. And this guy's MV naught. So what if we try substituting this in for K? That will give us H bar over 2 root ME, right? over E cosine. By the fourth plus m v naught. All right. This guy is going to cancel this to 2. Cancel one of these guys. This guy can cancel one of those. He cancels the square root. Well, this is not really what I wanted to get. This is too complicated. I think I'm missing some kind of simplifying assumption, or I didn't cancel something I was supposed to. I mean, let's think about this. When V naught, so let's just think logically about whether this even makes physical sense at all. So when V naught goes to 0, we should expect this whole mess to result in 0 reflection. Is that true? Well, what happens when V naught goes to 0? We get so right off the bat, I know this is wrong. Because when V naught goes to 0, this should be 0. So where did I make my mistake? Maybe in calculating all this stuff out. You know what? Rather than dig through and try to solve the last little bits of this problem, I'm just going to look at the answer here. But I am going to make a note that I might want to develop a more rigorous procedure for doing these kinds of questions. So I want to do 7.5a. So how did they get rid of these? Oh boy. All right. Note. So all those became 0. Wow. All right. That was pretty stupid of me. So we have A plus B is equal to C, and we have IK. C plus B minus A is equal to minus 2M E naught. C. This is the second problem I've had, is that I'm forgetting to attach this to the C. So, second mistake. I'm adding Y. Why is this the case? This is supposed to be h bar squared. What am I doing? So let me write that in the fine technique, because I think this is something that I've been getting wrong a lot. So, all right. So I think the logic here is we have phi prime of E at 0 plus minus phi prime of E at 0 minus. Yeah, I have to go over this again. It kind of makes sense, but so let's just see if I can solve it based on just these guys here. So A divided by B. We want everything divided by A. So we have BA plus C over A to 1. And so we have, let's do and this guy is equal to R, and this guy is equal to T. And so we have and then we want to get and then this R you can see is equal to 1 minus T. No, that just gives us 0. Go B, go C minus A, C. Divide everything by A, IK. Because K is equal to 2ME over H bar, this becomes 1 over I plus So let's see if that's right. Oh, they didn't in terms of K. I am V naught. What did I do wrong here? Oh, this is minus IK. All right, this is IK. So we get 1, 1, and then this is going to be divided by IK. So we can have minus I minus IK. Right, and then this will be C over A is equal to 1 over 1 minus I m V naught over K H bar squared. And then and then B over A is equal to 1 minus over K H bar squared. Get that right. No. What did I do? All right. I think I need to work through this procedure with the Feynman technique. Do I want to do that now, or do I want to go through all the problems first? You know what? I think I'm going to move on, but I've made a note of it here. I think just doing it right now, it's too soon. I think it'd be better to wait until I've made some distance. But I'm going to just cross this out, and I'm going to put just do 7.5 A again. All right. Let's go on to 8.1 C. Okay. Given the state R not above, what is the state R not T? Or sine not? What am I doing? This times the energy, right? So I have pi I 5y plus c divided by L times e to the I e over h bar t. Do we know what the energy is? This. Do I have to split this apart? What would the energy be? E is equal to, hold on a second. So if I'm not mistaken, we have to figure out so the energy is going to be this 3 over L. I think it's 3 over L. 5 over L squared plus 1 over L squared. And this is, it's E is equal to K squared H bar squared over 2M, right? Should be right. So we're going to have this. So this is 9, 25, and 1. Is it not? Two M L squared. What would be my guess is what C is. Oh, what happened here? Yep. And C, oh, what's happening here? C is, it's minus I. Okay, so this question is right. I forgot the minus sign, but it's not the end of the world. Okay, 8.1C, let's cross this guy off. No, we have 8.5A. 8.5. Angular momenta and uncertainty. Commutator relations you derive in problem 3 imply an importance of uncertainty relations among the same angular momenta. What did I want to do? A. So we want show Lx equals Ly equals 0. For so we've got a spherical harmonic with Lm. So this is going to be see if I can remember my things. This is going to be what is the Lx? This is it Ly minus I Lz? I think they should have them on this formula sheet. Oh, interesting. There doesn't seem to be a they've got all these other things about the eigenmoment, but they don't have the basic operators. So I should make some new flashcards for that real quick because that's going to be pretty important. I forgot to do my flashcards this morning, so I should do them. Should do them soon. All right, let's flip these guys. So, did I already write them down? I don't think so. And Lx, let me get the, I think they must have them up here somewhere. That's the spherical coordinates. Ah, okay. So Lx is equal to ypx ypz. Already writing it wrong. Z minus ZPY. All right. Now we want LY. And we have ZPX, yeah. ZPX minus XPZ. LZ is equal to this one's going to be XPY. Yeah, XPY minus YPX. All right. Done some flashcards now. We've got a blank for the future. My little stack of flashcards is growing. All right. Oops. So I'm going to show this is now, if I can remember properly, this is now YP ZPY. Let me look. Forgetting it already. YPZ, yeah. YPZ minus ZPY. So, where are we? Oh, this is 3. We're on question 5A. Is L and L minus? Do we have the commutation relations here? 3. Equals 0. So I don't know whether I want to do this. I want to do so can we add in 0 here? So we go LX minus I will also go LX minus ILY plus ILY. Then we have psi. This is L minus plus ILY psi. And I believe these are orthogonal from each other, right? These should be orthogonal from each other. What if I do this? We want to add the L plus. Okay, so we got LX. Hmm. So what if we did, I don't know whether I can do this, but let's say, what if we did this? We have L and L plus are adjoints. I still don't think that's going to work because it's still a plus sign here. Well, I can't just lower the whole thing. Can I? What if we did this way? Psi, so psi, let's just go YLM is equal to L. So we could do L plus LM plus 1, L plus, we're going to try to do LX, YLM, this is minus 1. And so this is L plus YLM minus 1. Or L plus, what was that? That was Ly plus ILZ, right? Not LX. No, one sec. LX. So we have LX. But we should be able to commute this over. So we have now. Can we do that? Do we want to do that? I don't know if this helps us either. And commute this through and lower this down by another one. If I'm not mistaken, L minus L plus LX Y LM minus 1. If I commute it through, I should get a plus 1. Do I have a commutation relation for the... So these commute, so I should just be able to go L plus L minus Lx, y, Lm minus 1. And what is this commutation relation? Do I have it? So maybe let's just expand here now. Y, L, M minus 1. L plus. And then this is Lx minus ILY X. And then what do we have here? Y. Well, the X is just going to commute through, and this is going to commute through with a minus I h bar. Okay, 1 second. Minus ILY. It's going to be minus I times minus IH bar L Z. All right, that's not helping me. Yeah, this is a tricky one. I have no idea how to do this. Hey, Metan. I'm doing all right. I'm struggling on this question, though, and I've done it before, which means that I should have some hint of how to do it. Yeah, I've done this exact question. I mean, it was like over a week ago or something, but I wrote it down because I didn't get it right the first time. what does this commute through to? And figured this out. Yeah, I just, yeah. I think you're probably right. I actually have to get back to some other things. I've got a call in a few minutes, so I will jump over to that now. So I'm going to take a break, per Matan's advice, and I will be back this afternoon for a bit of a longer session. So I only did about an hour and 45 minutes, which is a little bit, not really that much time for me compared to what I have been doing. You know what? Maybe I'll just do some of these flashcards real quick because I'm always forgetting to do the flashcards. Shuffle these guys up, run through a quick set of these flashcards. All right. So let's go through them real quick. This should be a cubed divided by 2 times root pi. Yep. Units of h bar is kilograms meters squared divided by seconds. 10 hyperbolic 10 is exponentials. Oh, this is e to the kx plus e to the minus kx divided by e to the kx minus e to the minus kx. Oh, I did it the wrong way. Oh yeah, because it's a sine over cosine. All right. This one is e to the kx minus e to the minus kx over 2, right? What is this guy? This guy should be a times root pi. This guy should be I sine ikx minus I sine ikx. Yes. And this is 1 over root L, or meters. Energy in terms of a plus or minus for the harmonic oscillator. It's a plus a minus plus 1/2, and that's all in brackets times h bar omega. L plus 1 plus h bar squared, right? What is G naught? Root L times root mv over h bar. 2 mv. Okay, yeah. Lx is py, no, xpy minus yp, no, this is z, no, ypz minus zpy. Yeah, that's the wavelength. H bar k is equal to momentum, which is equal to mv. So we have mv is equal to h bar over h bar lambda divided by 2 pi. So we have 2 pi mv over h bar. 2 pi h bar over mv. Lz is equal to x py minus y px. Oh, derivative of cosine h is sine h. Oh, demonstrated is d phi? No. D phi? IH bar d phi. Right, okay. Ly is x pz minus z px. Lz ylm should be, this is just h bar m. Ylm, right? E to the kx plus e to the minus kx over 2. And then this guy is oh, 0, right? Okay. Shuffle these guys up. Yeah, so I've just been trying to, whenever there are facts to recall, meaning that this is just stuff that I should just have memorized, I have been making little flashcards. I made more than I thought I was going to make, but there's a lot of like little tiny little identities and things like that, often even from previous classes that are expected to be in long-term memory, which I don't always have perfect. And I just want to get some of these guys done. I'm just doing them maybe once a day. I might do them a couple times before the exam. I'm not really doing anything long-term to keep them in there. This is just short-term. I don't think I'm going to invest the effort to keep it long-term. So I will get back to this question when I return. I'm going to be off for a bit for lunch, and then I'm going to try to go a little bit earlier today. We'll see how it goes, and then hopefully I can put in, a good 4 hours this afternoon, so I can make my kind of rough 6-hour benchmark. I might even get this question when I'm back. So thanks everyone for thanks everyone for following this. I'll be back soon.